I've already discovered that motor efficiency has a big impact on the total cost of ownership. In this module, we will focus on 4 additional steps to take when selecting a motor, which can be remembered using this handy acronym: Requirements, Infrastructure, Standards, and Environment, or RISE for short. Sizing the motor correctly is very important. A motor is correctly sized when it runs at the rated torque and speed, delivering the rated power output whilst consuming the rated input current. To find out where this rated operation point is, we can look at the torque curve of the machine. Starting or locked rotor torque is produced when the rotor is not yet turning. This must exceed the load torque for the motor to accelerate the load. Pull-up torque is produced as the load accelerates and motor speed increases. The motor will stall if the load exceeds this value. Breakdown or pull-out torque is the maximum torque that a motor can produce in the operating speed range. And full load is the maximum torque that the motor can sustain in continuous operation without overheating. For the starting phase, we need to check the moment of inertia of the load. High inertia loads at startup generate extreme heat. We also need to check whether the motor will be connected directly to the main supply to run at fixed speed, or if it'll be controlled by a variable speed drive. This is important as direct on-line motors, especially those driving heavy fans or pumps, need a high starting torque, whereas those connected to a variable speed drive can have a controlled start with less impact on the grid. When calculating torque, it is important to assess the needs of the application, as undersizing the motor will lead to overheating, shortening the life of the motor. Conversely, an oversized motor could be a waste of money. Not only are you buying more equipment than you need, but the running costs will be higher as the duty point will be too low on the motor efficiency curve.